So welcome to Java Anti-Patterns. My name is Vitaly. I'm an engineer from here in Columbus, Ohio. Today we're going to look at various things you should not do and some of the things you should do in your Java code. We're going to look at some of the patterns. Some of you have probably seen. I've seen a lot of them. And we're trying to learn a few things maybe that we can avoid them in the future. We're going to look at some of real-world examples. Raise your hand if any one of you maintained a single class with over 3,000 lines of code. It's a little light here, but yeah, some hands. Anyone fixed one bug to have two other things break? Yeah. Anyone seen code like this, where you see status equals 7, but then you don't know what 7 is? There's no doc. There's no comment. Anyone seen exception, like catch block, with just empty curly braces in the code running in production? Yeah. Yeah, so you're in the right place. We're going to look at some of these things here and see what we can do about it. First, let's define what the anti-pattern is. Term was coined by Andrew Koenig in 1995. And he says anti-pattern is just like a pattern, except instead of solution, it gives you something that looks very superficial to a solution, but it's not one. And we can break them into a few different tiers. Some of them are annoying. They just add friction. They waste your time. Then they confuse juniors, so they confuse people new to your code base. Some of them are actually dangerous. They cause bugs. They block some features. They pile up tech debt. They can cause consumer harm. And speaking of that, there's some that are really career-ending, where you lose your data, you can get sued, you can be hacked, you can have outages. Now let's look at a few of their second, let me reload my notes. A few of the usual suspects. God object, spaghetti code, lava flow. Sorry. Here you go. Sorry, I had some tech difficulties in the beginning. And then some of the yellow ones are the annoying ones, like copy-paste, where you would copy code from one place to another. And I'll show you some examples. Ostrich effect and compound effect later, that are just multiplier, where a few of them are piling up on top of each other. So let's look first of the God object. Sometimes people call it a blob. If you worked with enterprise Java, or if you work in a big company, you've probably seen one. If you ever had something called app manager, system controller, or just utils, anything with utils, you have a God object. It's just something that does way too much. Methods can be not even related to each other. If you have a problem in one line, you probably have problems elsewhere. It's very hard to test God object. You have to do a lot of mocks and a lot of setup to test it. Some example, abstract bean factory. If you have something like that in your name, you know you have God object. It has too many lines of code, too many object creations, dependency resolutions, type conversions, just too much stuff going on. So everything relies on it. All your services, all your database connections, things like that. So here's a very trimmed example. So you can see, yeah, where example of app manager, and you have method that says, hey, create a user. But if you really look through it, you see that it does validation. It talks to a database, inserts something. It sends an email. It tracks it through analytics service. It even has some business logic, if statements, and then 100 other unrelated things inside that method. So few things you can do. You can break it down into separate classes that are just doing one thing at a time. So as you see here, you have your user validator, notification service, and each of them do their own thing that you refer to in your code. And in your register method, you just call them. Key insight is that you can also use record type, as you see at the top, the very first line here, where your create user request has record with name and email, and you also, by doing that, eliminate a lot of boilerplate code, getters, setters, all the other methods that you're probably tired of writing. Another pattern is spaghetti code. Everything is just so intertwinkled, or you have all these nested if statement. If you just didn't even see the code, it kind of looks like this arrowhead pattern where everything's nested, and then you have to close all the parentheses, and kind of looks bad, but then also it has a lot of kind of cognitive load if you're trying to read it. So you have to say, hey, if order is null, so now you have to track this in your brain. Then if items are null, not null, sorry, and then you check, hey, are the size are greater than 0? You just keep checking these things, but by the time you get to process item, you probably forgot first few checks you did. So how can you address this? So one way to do is to use guard clauses where you do all these checks in a single if statement and you immediately return. So you kind of flip all the checks and then return. So your order is not null. If it is null, you return. If there's no items, you also return. And then only then you get to actual logic, and you know that, hey, I've done all my checks. I don't have to track all the braces, and I just can process my order now. Makes it more flat and readable, and there's no crazy nestings. So next thing we're going to look is lava flow. Just like dead lava, dead code solidifies and stays there forever, and everyone is afraid to touch it. This is actually a real example from Apache Tomcat, where this method was deprecated since 2002. It was marked as deprecated, but it was kept around for years just for backward compatibility, where for 22 years it was not removed it. And so now in Java, since Java 9, they added kind of enhanced deprecated tag where you can say, hey, since when it was deprecated, and you can say that it's marked for removal and set it as true. So now if somebody looks at it, they know, hey, I'm better not use this method. If I call it, I want to remove it from my code base because it's due for removal and can be removed soon. And the number one is Git is your safety net. If you ever want to see what code was there, you just go and look in the Git history. If you delete that code, it'll still be there in history. If you ever need to see what was there before, or for any reason even restore it, you can do it through Git. You can also see in your coverage reports, if nothing refers to that code, you probably are safe to delete it. If there's 0 lines, if these 0 execution paths are hitting it, you should be good. Hardest part is not to just delete it. Hardest part is just to start and kind of be the person to do it. Magic numbers and hard coding. A few real examples here from Java util calendar where months are 0 indexed. So when you say, hey, January is technically first month, but the index is 0. So if you have this cal.set 2026 015, now you have to do like mental computation. Hey, what is 0 in that case? If you had 1, maybe you know, but if it's 1, 2, is it January 2nd or is it February 2nd? It's kind of hard to tell. Or where you have day of week and equals 7. What is the 7th day of the week? Is it Saturday or Sunday? Like, do you remember? Now I have to Google it. What does it mean in the context of this library? And these APIs confused developers for years. And things like hard-coding connection strings or timeouts is another example of magic numbers in hard coding. If you put your database connection string like that in your code, you just checked in your source and shipped it to production. Or if you have timeout of 30,000, is it 30 seconds? Is it milliseconds? You don't really specify here. By just quick reading, you cannot really tell. So what can you do? Well, let's start from the bottom. For externalize, you would externalize your config. You would put DB URL in the code, but then you would annotate it like so over here with value, DB URL, and you put it in your environment variables. And your dev and prod would have different values. And what we also do, we put things like that in key vaults at work where they can actually be secret and just referred by a variable in config. And you would just use duration class where you definitely see that, hey, this 30 is seconds. And I don't even need to put any comments because it's just self-explanatory. And for time, you just use libraries that's already available. You would use local date and day of week, and you just clearly say, hey, Saturday is Saturday. You don't refer to it by a number. And you don't have to put comment, you don't have to search. And if you just type days of week, IDE would auto-suggest you days, and you just click on your keyboard and pick the right day. You don't have to actually type it. And what I also see a lot, that people use string for everything. Email, account type, status, balance, everything is a string. Even though you may have only a few statuses or a few account types, I don't know, checking, saving, credit card, somebody can pass some other value for it. Why would you use string? Or if a status is 1 or 0 or X, what does it really mean? Now you have to put comments, now you have to document it. It's not clear for the next engineer that comes after you what it is. And then let's say you want to check if status is active. Now I have to worry about, is A capital, is the whole string lowercase, is the whole string uppercase? Now I have to have even more code to figure that out. And then if you're trying to parse the balance and convert it to a double, for whatever reason, you'll get an exception if value is not convertible. So what you could do is just use type-safe domain objects. For example, enums in case of account type or status. And if you just have few of them, it's perfect case for it. And if you type in your IDE account type dot, it will just autocomplete, and it'll suggest you checking or saving. If you're trying to pass something else, the code is not even going to compile. So you will catch it right away, even before you deploy that code anywhere. Same for comparing status. So you can, now that you know it's enum, you can compare and check, hey, is it active? You don't have to worry, lowercase, uppercase, anything like that. So here's the benefits. Compiler catches this before it ships anywhere. You don't have any surprises during runtime. I mentioned before copy-paste programming, where maybe you already have export PDF class, and now you need to create export CSV class. And somebody already wrote connect format data and save file method, and you just want to reuse them. So what some people do is just, hey, I'll just grab that whole method from one class and paste it in another class. And then I grab save file from one class and I paste it in another class. It'll work until later you realize maybe there was some bug in, let's say, format data, and somebody else will fix it and export PDF. But because you copy-pasted the older version, you're not going to know about it, and your class will have that defect. One of the solutions to this is the template method pattern, where you put the methods that are shared or reused in few places into abstract class. And then let's say your write output is different, right? Because you want to save to CSV instead of PDF. You will have your own version of it in your class, but the connect and format data would be shared between them in the parent abstract class. So kind of pretty easy solution. A lot of times I see reinvent the wheel pattern. Like I mentioned, some of you who work in enterprises, a lot of us have collection helpers, string helpers, string utils where standard library already exists for years, but for whatever reason we decided to write our own empty check, or maybe we want to join two strings together and we have our better way to do it, only to realize, hey, this been in place for years, it's battle tested by multiple projects and millions of engineers. Why would you reinvent your own wheel? So before you roll out your own, see if somebody has already solved this problem. So solution here, just use collection utils or string.join or any other methods from the string package. Like if there's any defects in those methods, you know, they will fix it, and they've been running in production for years, so they're much more stable than what you probably would have. Now let's look at some subtle traps that probably look like good ideas, but in reality maybe are not. You might be praised by your tech lead for doing some of these things, but until it bites the whole team. So one of them is premature optimization, when you're trying to be too cute and pre-optimize something that maybe doesn't really need to be optimized just yet. Or, for example, if you have like a batch job that processes 50 records per day or twice a day, you don't want to roll out your own like thread pool solution and tune it with various parameters and you know, just maintain dozens of lines of code for it, right? If it's something that doesn't need that high of a performance and runs pretty quick, just use something that's already there. If you're on Java 21 and later, you could use virtual threads. I give example here. If you use Spring, just annotate with async. And you don't have to have all that boilerplate code for that. Accidental complexity applies not just for Java probably, but this is where you're trying to solve something but just overcomplicate it. If you build a small to-do app for one user or a few users, you probably don't need API gateway and Kafka and few databases and all this complex infrastructure. It'll be just too many lines of config to maintain. You'll pay too much for infrastructure. It'll be too complex to troubleshoot. Just start simple. Maybe it's a Spring Boot app with SQLite and just 2 endpoints. Give me my old to-dos and save it to do. And maybe, I don't know, check off a to-do item from a to-do list. Just few endpoints and simple database, simple and cheap. And then once it explodes in popularity, maybe that's when you start adding more layers and more complexity to it. So let's look at ostrich effect. Just like ostrich that buries its hand in the sand, this one is kind of similar. This is where you have your catch block, but it's empty. Nothing happens. Maybe you have a code that should charge a customer card for an order that he has, but then the error happens, but nothing happens in the catch block. You have a comment saying, hey, to do, fix this later, and we've seen this a few times. We don't want to pollute the logs, so we're just coming out and we don't do anything. But then code silently continues, and maybe we want to ship the order, but that's not what we want to do if the customer didn't pay. And now because you see this happening, you're not going to see the logs. So you'll see we are shipping orders, but we're not being charged for it. And if you're trying to troubleshoot, you're not going to see logs. Now somebody has to know the code pretty well to find this kind of problem. Solution here is a few things. First of all, you never want to have empty catch block. You want to catch specific exception, for example, payment exception. So what happens, what will you do if payment failed? First of all, you want to log something maybe. Think if I'm on an outage call at 3 a.m., what kind of information I'll need at that time. Maybe I'll need the order ID or customer ID. Maybe I want to have some ID to be able to search, hey, this customer tried to pay, let's see, let's debug what happened, right? And maybe we want to mark this order as failed in another service and system. And maybe we want to send an alert to somebody on call or send a message, whatever tool you use. And so you either recover manually or rethrow. So whoever called this whole piece of code, they would now have to handle it as well. Maybe you mark payment as failed, and then the order is never shipped. Customer probably won't be happy, but at least you didn't get that loss as well, where now you're shipping products without charging for them. The golden hammer is where if you have a hammer, now everything looks like a nail. Maybe you want a cron job, and somebody says, let's use Spring Boot. CLI tool, let's use Spring Boot. Maybe we need a static front-end page. We can do it in Spring Boot too. Well, maybe that's not the best solution for everything, right? Or I've seen where somebody gets into Kafka and they just want to use it for everything. Two services talking to each other, sending an email, even for login, right? Send a message to Kafka, we'll log that in the login service. You don't want to also, I know there's very few talks, like whole talks on microservices, and pretty good information there. Like you don't want to use microservices for everything. If your app is very simple, sometimes actually maybe you want to have a mini monolith if there's really no need to scale it, right? If you want to keep it simple, why would you split it into so many pieces that you have to separately maintain? So what you want to do is you define your problem first, see what constraints you have, and then you pick a technology. And Spring Boot or Kafka might be the right tools, but you don't pick them first and then define the problem. You kind of do it in reverse. And you also want to evaluate at least one more option, right? Maybe a few people say, let's go with Spring Boot, but did anyone consider any other options? Maybe let's talk about it. And yeah, maybe Spring Boot is the right choice, but at least we've considered some alternatives. But sometimes the simplest tool is the one that will actually solve the problem. Now let's talk about a few other patterns. Some of it is about concurrency, where you're not really going to see the problem unless some specific conditions happen. And oftentimes it's in production under heavy load. Like, for example, here you have something that works perfectly in test, but compiler, in this case, can reorder instructions. And on the right load, you will see, hey, I check here for null, good. It is null. Then I go to next. I have this synchronized block, check for null again the second time. But you have the partially constructed objects. And you'll have corrupted state. And what you could do, when you add the volatile statement, it'll prevent just-in-time compiler reordering, and it's available since Java 5, but even better, you have this holder pattern where you have a static class, and now the JVM will guarantee the thread-safe class initialization. This is from Joshua Block, Effective Java. He has a lot of patterns like that, especially for concurrency, if you want to dive a little deeper on that. So now I mentioned microservices, and sometimes you think you have microservices, but in reality you have a lot of separate services that still have shared database behind them. They share one database. If you change the data structure in one, and then the other now depends on it. So you cannot really deploy one without the other. You now have to worry about syncing the deployment time. Maybe the second service is owned by another team. So we had different problems at that point. So services sharing the database, and one calls each other, same for deployment. So if you have all that, you don't really have microservices. Maybe you have kind of quote-unquote apps that are separate, but they just act as distributed monolith at that point with extra network hops. You actually, in this case, you might want to stay as monolith until you really have a reason to scale it to more system. But oftentimes, until you have that big of a growth, you don't need to do that. Now, compound effect, where some of the patterns I mentioned compound one on top of each other. So you might start with God object, and lines of code keeps growing, number of methods keeps growing in it, and maybe somebody is afraid to touch it, so they'll just copy some code out of it into their own method or class. And then you have lava flow, where now you have code that's unused and nobody knows what it does, or nobody wants to delete because I don't want to be the guy who deleted it and maybe broke something. And it just piles on, and the whole system becomes maintainable. So researchers look into it, and what the results show, where you see more than 3 of these kind of patterns, you're 5 times more likely to have a major rewrite in next few years. So like that's where your CTO comes in and says, hey, let's rewrite, let's migrate, this just doesn't work. But where it started, oftentimes, is just piling up of all these patterns in your code. So this is from IEEE software in 2019. So, I mean, I told you a lot about like what not to do, but maybe sometimes it's actually acceptable, some of these things. Maybe you are working on a prototype or quick spike, and I don't want to split everything into dozens of classes, and I know that the code will be a throwaway, so I think it's fine to have a God object and a big class. As long as you know that it's not going to go to production to actual customers, as long as you know that you'll delete it later. Maybe some frameworks actually force you into some patterns. And hey, inherited this project, and we have established patterns, and maybe we use JPA entity annotation. So that's just kind of where we are. Until we move to something else, that's where we're going to be. And if you are at early phase, right, maybe you just want to launch your product, so you can do something quick and dirty. You don't want to have the perfect architecture, and speed to market is maybe more important at that time. But you want to schedule a cleanup. At some point of time, you want to review your work, saying, hey, we've been a year in business, maybe it's time to grow up and fix a lot of things. And well, when it's not okay, I say when it's probably okay, it's not okay when you say we'll fix it later, but there's no ticket, there's no deadline, and no owner. So like I said, maybe you do something quick, you're launching, but you want to take a note for yourself in whatever system you use for it. Sometime later, let's review, let's fix, let's clean up. You don't want to say it works, don't touch it. Maybe it works without any tests. Why would you change? Why? Nobody understands it, but I'm not going to be the one that touches it. And maybe you say, hey, everyone else is doing like that. We just copy in. I see this code always worked. Other teams are using it. Why? I'll just go and copy it as well and paste it into my section. And you also don't want to abstract too many things. Maybe some condition will never happen. You don't want to write layers on top of layers of abstraction. So use it only when it's really needed. Let's look at one of the examples of one of the biggest defects and security vulnerabilities in Java from 2021, the log4j, log4shell in log4j library, which was a level 10 CV vulnerability. They actually had a few anti-patterns there. They had magic string, they had lava flow, they had accidental complexity and ostrich effect. They had magic string processing where the log message would actually evaluate the expression that you pass, and they would evaluate it as code. And yeah, you can see there, there's this particular JNDI string that actually was the whole problem. If you pass it to a logger line, it would actually execute it, and that's where lies the vulnerability. And researchers warned about it, saying, hey, there's possible injection here. It was just never exploited until 2021. And then based on that, a lot of other packages obviously use this logging, right? And so now a lot of projects, a lot of companies had to scramble to update and patch, and it just cost so much money in remediation. And there's probably still applications that run vulnerable versions list of the day, but a lot of it has been patched, but some companies obviously did it slower than the others. So a few lessons from that is that login library should never evaluate user input, right? You don't trust your user. Even you might love your users, but you don't trust them. You don't know who will be your user, who will be passing input into your system. Old features without active maintenance become time bombs. Now with AI, they actually don't want to release some of the AI models because they claim they can find vulnerabilities in everything. And you just don't know when these models will end up in the wrong hands and your code will be exploited. Every line of code is attack surface. Like I mentioned, if you do your own collection utils, your own string parsing, your own string or any other helpers, the more lines of code you have there, the more and the bigger attack surface is. Let's talk about a few principles that prevent anti-patterns from forming. So kind of back to basics from Bob Martin's book and some of his, like one of his quotes is, variable names should answer all the big questions. You don't want to declare the variable, but then have a comment explaining what it is. Maybe you have variable name t, and when you write it, it makes sense to you, but a month later, maybe, how do you even search for t, right? If you grab for t or search for t, just so many things will come back. It'll be much harder for somebody else to search. Same, I talk about account status, right? What is 7? Active, deleted, like nobody knows, right? Now you have to comment it, document it somewhere. It's just not obvious. Maybe the only thing I'll kind of allow is if you're doing a loop, I is acceptable. It's just everyone's using it. And if for whatever reason you need another loop inside of that, maybe you can use J, but maybe that's like few exceptions. And even so, some people say that even that's not a good practice. So you want your variable names are searchable and intentional. So think, hey, month later, I'll search for this. Maybe it's, instead of t, if I say transaction amount, now I can search it. Now I don't even need a comment. I just know what this variable represents. Again, I talked before, use enums. They also searchable, they type safe. And in loops, if you don't need index, because not every loop needs an index, right? Maybe you're just going through a list of accounts. Give it a meaningful name there as well. Also, don't try to be too cute. Use professional words that everyone else would assume. Use for your classes nouns in singular. For methods, use verbs. Start with lowercase. For a lot of engineers, it's kind of obvious, but it needs to be reinforced, I think. For Booleans, use predicates in form of is active, can execute. So kind of a little verb, and then the predicate after that. You don't need any like underlines from maybe some other languages. Now, a few things about functions. There's 2 rules. Number one is the functions should be small. Number two, that they should be even smaller than that. Functions should just do one thing. I know I talked earlier where hey, I send email, I send the order, I track it in an analytics service. You don't want to have all of that in one function. You need to have separate function for each of those steps. Functions should have ideally less than 3 arguments. They should not be taking a lot of width on your screen. And they shouldn't have any side effects. So if you say get user, that function should just get user. It should not send any emails. It should not do anything else. At this point, now it has more action that it does. I see a lot of this where, first of all, it's more than 3 arguments, but it also has a lot of Boolean arguments, and you don't really, kind of by reading, when you pass it, you don't understand what it does. You can look at the method signature, say, hey, the first one is urgent, the second one is add attachment, and then another one, BCC manager. But I think you can still do better. First of all, you can replace the Boolean for if it can be urgent, maybe medium urgent, or not urgent. You give it a enum with 3 different values. And if you have only a few types of shipping, you can also create enum for it. And now when you call this method, compiler will help you and your IDE or even your coding agent to kind of autocomplete the right values, right? And also like a builder pattern, like I give here an example too. Just do say, hey, it's dot urgent, dot with this attachment. Or you can also have separate methods. Like why would you call process and pass all this info? Maybe you have separate method for send an email and send one with attachment, and it has different parameter to it. And call out here is if Boolean parameter is not obvious from the caller point of view, it means it should not probably be a Boolean. So few things how to refactor a monolith. So methods like here, just like a lot of things going on. You see, maybe I set up a page and I set up a string builder and page crawler, and I build this string through all these steps, and I do a lot of appending logic. You want to abstract it. Maybe you just have one method, and it's okay to give it a bigger and longer name, like include setup and tear down pages. And now from just the name, you can kind of tell what's going on. If you want to see all the string building and everything else that's happening inside, you just click into it and see the logic inside. But if you just want to kind of read this method and see high level what's going on, it's nice to see that it's abstracted into a separate function and fits on one screen, tells you what's going on, doesn't tell you how it's happening, and just has one level of abstraction there. So here's about side effect actually in Spring, where you have get order summary method, and maybe you find the order by ID, but then the line, I guess 4 there, you set last viewed at, right? Because maybe I find the order and I want to mark it that somebody viewed it. Now I set the field last view at, and now it actually writes it back to the database. But the method name, it just says get order summary. Nothing told me here that it will update something in the database. So maybe you want to do something like that. You have your get order summary. If you cannot find it, you throw, but then you have a method which says record order viewed, and you use that to mark the last viewed field with the current timestamp. Error handling. So if you have like method like this, find user, where it could be null, now it's up to a caller to handle it. Now you made their life harder. So use optional that are available since Java 8. You return, instead of user, you return optional user. And now whoever's calling this method is actually forced to handle absence. Now, if they find it, they maybe get the name out of the user for their purpose, or they'll get unknown name. and code just not going to compile if they don't handle it. And a few examples of bad code, I think you can see there. I don't like where people put like, hey, on this date, this person changed this, and they keep kind of writing a log or like a whole book who did what in a code. Just use Git. If you want to see who touched this line, just go in history and see that. And maybe the one line was changed many times. You could do that as well. Noise comments, you don't want to say, hey, day of month, that it means day of month. Or maybe you create in a constructor, you don't want to say that I create a constructor. I think it just kind of wastes you restating the obvious. Position marker, if you have all these nested ifs and loops, I've seen where people would say, hey, this ends this if, and this ends this method, and this one maybe end of the loop. I think if you have to do it, it means that your function is too big, has too many conditions, and complexity is just too high. Ghost code, I mean, I've done it. I probably still need to do better at removing it. I have commented out code that still sits there, and you know, it was there at some point. It was active, but we don't need it now. But it's not removed. It's just commented out for now. Stale to-dos. A lot of them sit there for years. Well, we need to fix something here, or maybe there's potential bugs, but I don't have time right now. So let me just edit to-do and commit it with my current code, and then it just keeps staying there forever. Ideally, you would scan weekly through your to-dos and do something about it. Either delete it if it's not a problem, or create an item, assign it to someone, or fix it yourself. Maybe example of a good comment is where you explain something unavoidable, where you have to do some workaround, and after some other team fixes something else, that's when you remove it. So maybe that's the place where it is fine. And then some features in modern Java where these features just by their existence make it easier to just not have these anti-patterns. Like records I mentioned before, now your code is smaller. You don't have to write DTOs, getters, setters. You have seal classes where they replace open inheritors, where you can say, hey, only these classes can inherit. And better pattern matching since Java 21. Just much easier to use. A few things that I'll leave you with for when you get back to work on Monday. Make sure you have SonarQube and SonarLint running, and you address the smells and fix the problems that it flags, ideally before code even goes live. If not possible, maybe schedule a sprint for that, or assign it to one engineer as part of the work in the sprint. Use some other tools that are available that help you like spot bugs, find null, dereference, infinite loops, resource leaks at bytecode level. If you can get them, use them. If you have to explain why in a comment, you probably want to refactor that code. And one of my favorites, even if I work on something else, if I see that I can clean up something I related, I'll do it. Sometimes I'll get feedback, hey, your PR is too big, you fix some random thing that's not really for this ticket, do it later. I sometimes try to push back on that, but I think it's a good rule to have. Yes, so 3 things. Prevent, use SonarLint. If you can get it in your IDE, you can also get it in your pipeline, in your CI. You can eliminate bugs as you go, or eliminate small problems as a Boy Scout rule, and just educate others, right? Show this presentation to them. Show some of the patterns to your teammates. Some of the books or resources are really good ones here, and I'll show you a link to slides in a second. so you don't have to take a picture. And yes, here it is. If you want a copy of slides, just scan this QR code or go to this bit.ly link where you can get a copy. Thank you so much.